Gliese 12b. Gliese 12b is the new kid on the cosmic block. It was announced in 2024 and is already stirring up headlines like it's the next big thing in real estate. Orbiting a red dwarf star just 40 light-years away, this planet might be Earth's warm, slightly sweaty cousin. It's roughly Earth-sized, possibly a Venus look-alike, and orbits just close enough to its star to hang out in the habitable zone. The surface temperature is estimated at around 42 degrees Celsius or 107 degrees Fahrenheit, which means it's hot, but not your face melts off hot. Think Death Valley, not molten lava pit. And while scientists don't yet know if it has an atmosphere, they're watching closely. If it ends up with a breathable mix, it could be one of our best bets for life, or at least for not immediately dying upon arrival. Discovered using NASA's TESS and other telescopes, Gliese 12b is one of the most promising nearby finds. It's not Earth 2.0 just yet, but it's got the potential. And if it turns out to be more Earth than Venus, it might just earn itself a top spot on humanity's interstellar wish list. BD Plus 054868 AB. BD Plus 054868 AB might sound like a barcode, but it's actually one of the most dramatic celestial soap operas of 2025. Discovered via NASA's TESS and announced in January, this exoplanet is doing more than just orbiting its star. It's falling apart while doing it, literally. Unlike your average boring but stable planet, BD Plus 054868 AB is disintegrating so fast it's trailing a tail of dust like a cosmic comet with commitment issues. It's the space version of peeling out of a parking lot with your bumper still dragging behind you. This rare, crumbling world scenario makes scientists giddy, and it's why the James Webb Space Telescope is gearing up to take a closer look. They're hoping to learn what it's made of and how planets like this get shredded over time. Spoiler alert, it probably involves being way too close to its star and having terrible gravitational boundaries. We may be watching a planet die in real time, which is equal parts tragic and fascinating. Tie-Dye 1b. Discovered in November of 2024, Tie-Dye 1b isn't just new, it's newborn. At just 3 million years old, this gas-wrapped infant is officially the youngest transiting exoplanet ever found. If planets had baby photos, this would be still in the delivery room. Spotted by researchers at the University of North Carolina at Chapel Hill, Tie-Dye 1b is about the size of Jupiter, but way puffier, low density, and possibly on track to become a mini Neptune or a confused super-Earth. It zooms around its star in just 9 days, practically hugging it like a toddler refusing to let go. What made it visible is its rebellious tilt. Unlike most newborn planets still hidden in their dusty cribs, Tie-Dye 1b's orbit doesn't really align with its star disk. But this is a plus as it gives scientists a clear peek past the gas and chaos. This little planet is a big deal. It offers a rare live-action snapshot of how planets start, challenging long-held ideas about formation and alignment. Tie-Dye 1b isn't habitable, stable, or grown up in any sense, but it's loud, fast, out of line, and changing how we think planets are born. Honestly, it's kind of a star toddler with main character energy. And you would be giving major aura if you subbed and liked the video. 20 Leonis Minoris b. First spotted in 2020 and officially confirmed in 2024, 20 Leonis Minoris b is the kind of exoplanet that sounds like it belongs in a Roman census but actually lives in a binary star system in the constellation Leo Minor. It's a hot Neptune, not boiling but definitely not chill. It's clocking in at a minimum of 9.2 Earth masses and whipping around its star host every 31 days. This planet doesn't orbit just any star. Its host, 20 Leonis Minoris A, is a G-type main sequence star, the kind of star that knows how to keep things running smoothly. The whole system was observed as part of the NEID Earth Twin Survey, NETS, which is basically the space version of swiping through the galaxy for potential Earth lookalikes. Spoiler, this one's not Earth 2.0, but it's interesting. With its tight orbit and Neptune-like bulk, 20 Leonis Minoris b likely sports a thick atmosphere, maybe swirling with heat, pressure, and clouds that scream, "Do not enter." Barnard Star b. Forget what you heard in 201. Barnard b wasn't officially confirmed until October 2024. The earlier hype about a super-Earth turned out to be wishful thinking. What we do have now is a confirmed rocky exoplanet hugging one of our nearest stellar neighbors, Barnard Star, just 6 light-years from Earth. Barnard b isn't big and flashy. It's more like a compact, rugged off-roader in a tight orbit, circling its red dwarf star every 3.15 days. That's not a year, that's a long weekend. This thing zips around its star so fast, you barely finish unpacking before your birthday rolled around again. Because of its proximity to the star, it's likely roasting on one side and freezing on the other. Not ideal for vacationing, but fascinating for study. With the dust finally settled on its status, Barnard B joins the Exoplanet Club as a small but mighty neighbor. It may not have the glamour of Earth 2.0, but in exoplanet terms, being nearby, rocky, and real already makes it headline-worthy. Because this time, it brought the receipts. Gliese 341b. Discovered via transit in 2024 and confirmed by NASA in 2025, Gliese 341b is the little guy punching above its weight. Officially classified as a sub-Earth, it's just 0.92 times Earth's radius and about 0.72 Earth masses, basically Earth's smaller, hotter sibling who never moved out of the attic. It orbits a red dwarf star, Gliese 341, from just 0.0608 AU away, completing a full lap in 7.58 days. That's a new year every week, which is perfect if you love cake but hate aging. And with estimated temperatures hitting 287 degrees Celsius to 487 degrees Celsius, it's less beach vacation, more boil your boots. What's fascinating is the mystery swirling around its atmosphere or lack thereof. Scientists are using transmission spectroscopy with the James Webb Space Telescope to figure it out. So far, it might have a hazy, water-rich envelope, or it might be bone-dry and naked. But one thing's for sure, a heavy, thick atmosphere is off the table. Barnard Star C. Barnard Star just keeps giving, and Barnard Star C, confirmed in March of 2025, is the latest spark in its planetary fireworks show. Detected using the radial velocity method, this tiny exoplanet was revealed by measuring the star's subtle wobbles, like watching a dance partner sway because someone keeps tugging at their belt. This little world is just 0.335 Earth masses, making it a true lightweight in planetary terms. Think of it as a cosmic pebble skimming the surface of its star, orbiting at just 0.0274 AU and completing a full lap every 4.1 Earth days. Temperatures are estimated to be at least 67 degrees Celsius, which means it's not that kind of hot, just the "you're definitely not building condos here" kind. It's one of 4 confirmed planets zipping around Barnard Star, B, C, D, and E, each tucked in tight around this nearby red dwarf. At just 6 light-years away, Barnard Star is practically in our backyard, making it prime real estate for exoplanet hunters. Barnard Star C won't be hosting barbecues anytime soon, but it's helping rewrite what we know about small rocky planets crowding close to faint little stars. Barnard Star D. After decades of suspense, Barnard Star finally spilled the goods, and Barnard Star D, announced in 2025, is one of the 4 tiny secrets it was hiding. At just 0.263 Earth masses, this rocky sub-Earth is basically a space marble, tucked in so close to its red dwarf parent that it completes an orbit in just 2.3 days. That's blink twice and you've missed a year. Located a mere 0.0188 AU from Barnard Star, this planet is practically brushing up against the stellar surface. It's definitely not in the habitable zone, unless you think lava saunas are a lifestyle. This discovery was years in the making, built on a pile of data from every major planet-hunting telescope with an acronym, HARPS, UVES, Espresso, and the whole alphabet soup. The confirmation of D, along with B, C, and E, finally locked in Barnard Star as the host of a busy, compact planetary system. GJ2126b. Discovered and announced in early 2025, GJ2126b is a gas giant with drama. We're talking about a 1.3 Jupiter-mass planet on one of the most extreme orbits we've ever seen, eccentricity 0.85, orbiting its host M dwarf star every 272.7 days, and sometimes it gets so close to its star it's practically whispering sweet nothings. Then it slings out so far you'd think it ghosted the whole system. It's the kind of orbit that would make even Pluto dizzy. Israeli astronomers detected the planet using HARPS, the High-Accuracy Radial Velocity Planet Searcher, with over 100 measurements tracking the star's subtle wobbles. GJ2126b isn't habitable, and honestly, it doesn't care. It's big, bold, and orbiting like it's late for a meeting with destiny. If planets were characters, this one's a wild card with a gas giant ego and a flair for cosmic theatrics. 2M1510b. Discovered in April of 2025, 2M1510b is a rule breaker with a polar orbit. That means it circles its hosts, which are a pair of brown dwarfs, at a 90-degree angle, like it missed the memo about how gravity usually works. Its parent system, 2M1510AB, consists of two brown dwarfs, not quite stars, not quite planets, basically space's awkward middle children. These two eclipse each other regularly, creating a cosmic light show visible from Earth, but something was off. Astronomers noticed the timing was shifting, like someone was tugging on the system from above. Enter 2M1510b. Instead of lazily orbiting in the same flat plane like most planets, this rebel swings over the top, perpendicular to the brown dwarf's orbital plane. It's the first exoplanet ever discovered with a polar orbit around a binary system, making it a galactic oddball in all the best ways. Scientists still need more data to nail down its mass and orbital period, but one thing's clear. 2M1510b is helping redefine what normal means in exoplanet systems. GJ3998d. Announced in March of 2025, GJ3998d is the latest addition to the exoplanet family orbiting a red dwarf star just 59 light-years from Earth, and it might just be the system's most intriguing resident yet. It's a super-Earth, weighing in at around 6 times Earth's mass, and it lives right in the habitable zone of its star. That's the Goldilocks zone, not too hot, not too cold, where liquid water could hang around, assuming the planet has the right kind of atmosphere. And that's a big deal when your parent star is a red dwarf, the kind known for tossing out flares like cosmic fireworks. GJ3998d joins the two previously known planets in the system, but this one stands out. With its potential for temperate conditions and a thick protective atmosphere, it jumps high on the short list for future habitability studies. It's big, it's nearby, and it might be wet, which in the exoplanet world is the holy trifecta. Scientists are already eyeing it for follow-up with telescopes like JWST to see what it's hiding under the hood. TOI 6695b. Revealed in 2025, TOI 6695b is a gas giant with a light touch, literally. With only 0.21 Jupiter masses and a radius of 0.85 Jupiters, it floats in at a fluffy 0.41 grams per centimeter cubed. That's less density than a marshmallow in a microwave. It's a big world, but not a heavy one. Orbiting a red dwarf star at about 0.402 AU, it takes 80.4 days to complete one lap. Not too fast, not too slow. It's the outer player in a cosmic duet with sibling planet TOI 6695c, and the two are in a near 3-to-1 resonance, like celestial roommates, stepping on each other's orbital toes. Their interaction creates noticeable transit timing variations, which lets astronomers measure their gravitational tug-of-war in real time. TOI 6695b may not be habitable, being a gas giant and all, but it's still a dynamical gold mine. Studying this pair could help us understand how planets settle into their orbits, how systems stay stable, and how giant planets end up with the density of a puff pastry. In short, TOI 6695b isn't just another gas blob. It's light, weirdly squishy, and part of a perfectly choreographed orbital waltz worth watching. TOI 6695c. TOI 6695c is the heavyweight champ of its system, a gas giant with 1.45 times Jupiter's mass and a bloated estimated radius of 1.21 Jupiters. First confirmed in 2025, it orbits its star every 242.4 days, hanging out at a cozy 0.838 AU. It's the slow-moving bruiser in a two-planet dance, paired with its puffier, lighter sibling, TOI 6695b. This planetary duo was spotted using a combo of test photometry, ground-based follow-up, and radical velocity data from the Magellan telescopes. TOI 6695c is the anchor, the mass-heavy, orbit-steady big brother, making sure the family doesn't spin out of control. It's not habitable, but that's not the point. TOI 6695c helps map the chaotic, beautiful ballet of gravitational dynamics and gives scientists a clear lab for studying how gas giants behave when they're paired up and locked in a celestial rhythm. NGC 1333's 6 Rogue Planets. You ever feel like drifting through life with zero direction? Turns out planets do that too. And that's what the James Webb Space Telescope spotted in August of 2024. 6 rogue planets freely drifting inside NGC 1333, a star-forming region about 1,000 light-years away in the Perseus constellation. These aren't your garden variety exoplanets. They're starless, homeless, and downright rebellious. No sun, no orbit. Just pure gravitational freeloaders. Ranging from 5 to 10 Jupiter masses, these big boys float through space like cosmic hitchhikers who never caught a ride. One of them even has a dusty disk, which is usually a trait of stars, suggesting it was formed by collapsing gas and dust, just like stars do. Now that's a big twist. Turns out you don't have to be a star to be born like one. What does this mean? It means the universe might be slapping together planets in at least 2 different ways. The classic born in a disk around a star and the wild, I'm a planet, but I formed solo method. Space keeps dropping new planets like popcorn. Weird neighbors are weird, but still neighbors.